So hello, good afternoon. So if you haven't heard yet, I'm Kenny Grip. I'm the product management, part of product management at MySQL. And yeah, this talk, my last talk of the day, I'm getting pretty fried after 3.5 talks, is on Shell for VS Code. So I have shown this earlier today, kind of the REST interface, like the REST service using the VS Code plugin. And yeah, I'll show you a little bit things about it, what it can do. So Visual Studio Code is by far the most popular kind of developer environment tool these days. So in this Stack Overflow survey from 2022, you can see that 74% of the people responded say that they use Visual Studio Code. Which is, a lot if you compare it to all the other ones. Here's MySQL Shell for VS Code. We have basically, if you use MySQL Workbench, it's similar. I mean, it doesn't have all the functionality at this moment, but you can connect to your MySQL database straight from Visual Studio Code, basically. We have a notebook interface, and I'll show some demos. It's some recorded videos that I have on how all this works and how the notebook interface works, as well as like OCI integration, where you can connect. I think during the keynote this was mentioned by Wim this morning. You can just connect to a database in OCI, not using a public IP, but using the Bastion service, where the shell will do everything for you to configure the Bastion service, connect that SSH tunnel, and you connect to the database directly from your laptop. So this slide deck is just all demo, basically. I have a little summary slide that I'll show for each of them, and then I'll show how to get it up and running and how to do all the features. That's it. Unfortunately, the laser doesn't work through this screen, so I'll try to run around a little bit. So first of all, installation, quite easy. So here, this demo will not fail. So if you go to extensions, so it's an extension. So you search for MySQL Shell, then you'll find the MySQL Shell for VS Code plugin. Here we have this one, and you just click install, just like any other extension. So you press install, it will download it, install the extension for you, and then you end up with this interface where you need to go through some installation, where we need to do some certificate needs to be installed. Because in the background, there's MySQL Shell running. So you have to enter your username and password, and that's it. It's installed. And you will have a new button there, the MySQL Shell for VS Code button, which shows you the interface. So what happens is you have VS Code running, and MySQL Shell will run in the back end, and the shell is just, the VS Code is basically an interface on top of Shell, basically a web interface. That's kind of how VS Code works. Now, we want to add a database connection, so we have the database editor where you have all your connections, your active connections, your configured connections. It's changed a little bit since the last release. And then you can browse, find all the tables in there, the schemas, and all kinds of information. So let's go and create this connection, right? So we can click plus here, or that button where you have the overview, and we can add a new connection where the list of connections will be. Very similar to MySQL Workbench. Actually, this is developed by a lot of the people that work on Workbench also work on this project, so you can see the similarities a little bit. So we enter local hosts to connect, username, password. We can store the password, and that's basically the simplest way to connect using this. And then you have it on the left top in the database connections as well as there, and you can click on it, and you're in the notebook interface. You can then run queries, and you can instead of enter, you do command enter on a Mac, and you can see the schemas in this example. And yeah, you have a kind of an interactive terminal, a notebook interface. So let's see what you can do with this interface, because it has various features which are quite neat. So we have our database localhost, and we have the Sakila database, similar as this morning. We have some tables in there. and we can do show data of the actors table. So what will happen is it will be put into the notebook interface, and you'll have the output here. It doesn't show all rows, but the first 200 in this case. You can do show again of another, and you can see it becomes like this terminal output where you have multiple queries there. You can also modify previously run queries, and you can update the queries a little bit. You don't have to go on the, it's not a console, right? It's with the notebook interface, makes it easy. You can change it, say add where actor ID 35, bigger than 35, rerun that query, and it will update that. Default is SQL mode, but there's also a TypeScript mode. And using the TypeScript mode, you can access your data and write some TypeScript and do all kinds of things with it. So here we're running a query, select star from the Sakila database, the actors table, and we want to store this. And then, so here's what's going to happen. We're going to print it. Select everything from Sakila actor, print. And then you see a JSON output of the Sakila actor table. So that's shown here. Now, we can take it a step further, and we didn't type it now, but we can run a query and then render a pie graph. And we can say group by language, basically. Look at the amount of movies and group them by language, and then make a pie graph out of that. So with the notebook interface, you can just do that. You can also modify the pie graph, so that's just a part of TypeScript that you can run any TypeScript, right? So you can change the layout to become a donut, for example. Just as example, so update it, and then we'll show that as well. Let's see if this contains anything else. No, that's it. Next, the OCI MySQL Database Service integration that we have. So you can connect directly to your database DB system and access your infrastructure in OCI. But first, we need to configure our OCI profile. If you haven't configured your OCI profile on your laptop where you run VS Code yet, then you can do it. We'll show it here how it makes it easy. So you log in on cloud.oracle.com, get to user settings, and then API keys as a resource on the left. You click API keys, and you can add an API key. And using that, you can download the private and the public key, store that somewhere. So here we're creating the .oci. This is where your profile configuration is stored. So the .oci/config is the config file, and then we're storing kind of the API key in there. So here we're saving it. We download the public key too. Don't mind the file names. There's actually it's a public one that was downloaded, not the private. So this is a little bit of a typo in the movie. So we click add, and when you have an API key, it will show you the configuration. And you can copy this configuration, and then you have to put it in .oci/config. Or in the shell for VS Code, there's a button, like the settings wheel. Click on that, and it will open up the config for you, where you can copy-paste the configuration in there. If you download the OCI CLI, you can download that too and do OCI setup, and it will do the same for you. So you don't have to do it this way. There's many ways to do it, but yeah. The one thing that we need to, of course, have is the key file to that API key, and then refer to that. And we're changing the default to MySQL tooling, for example. So when we save this and refresh, you can see we have now access to our tenancy in OCI. And you have a set of compartments. So we use compartments quite a bit here. And we have the development subcompartment, the MDS development subcompartment, and then we have a list of our compute instances as well as database systems. So we can set it as the default. Here, it's the default compartment, just to make it easy. So you can see there's some computes REST endpoint running, but we want to connect to the database. So we do create connection with Bastion service. And what we have is the same here, but we do connect to OCI DB server using the MDS settings. And we use the internal IP address, not public IP address, but it will use the OCI Bastion service to connect to that network. So if we press OK here, it will take a while because the Bastion, if the Bastion service does not exist yet, it's the first time you're doing it, it needs to create a Bastion session, download the keys, be able to connect. So when you click on it, so we have the local host and the MDS DB system that we named, we can connect to it, which we'll do next. And I'll show you a little bit how to move data, dump and load data between them. So if you click on it, it will reuse an existing Bastion session here. So it connects using an SSH tunnel to the database. And you have the same notebook interface again, where you can run your queries. So we look at the version. This is 8029 U2 Cloud, which is a MySQL Database Service version. And you can open it there in the list here and see the same kind of tables, whatever is there. So what we want to do now is move the Sakila database from one to the other. So you have some development tables and you want to move it to an MDS. So you can dump from within Shell VS Code using the MySQL Shell dump feature. But it has a nice GUI on top of that here where you can just dump the data. Of course, this is on my local computer, so this is all fine. But if you have a big data set, don't do it through the VS Code. Use it, run Shell on a computer, something like that, that has network bandwidth and all this, of course. But for the purposes of the demo, it shows you can dump and load everything. So you can see there's tasks coming here, dumping schema, loading the schema. Nice for small data sets, right? MySQL Shell dump and load has a lot more functionality. It can be really fast when you run it. But yeah, here we're working on a laptop. So you can see that the schemas are in both the local host as well as the MySQL Database Service. And we can run queries, and it's the same as in the other one. And we have multiple notebooks. There's an editor on top, and you can switch between different notebooks you have running at the same time. So yeah, that's easy to use. Next is the integration that we have for MySQL HeatWave for analytics. For the people who's using HeatWave, okay, some people here, good. If you're running HeatWave queries, there is like troubleshooting HeatWave queries. It's kind of, you need to use optimizer tracing. I don't know if you use that. Well, we make this easy here, right? So first we can like kind of rescale the cluster if you want to increase the cluster. That's available through here. But you can also like do some, so creating the cluster, scaling the cluster, but also run certain queries and troubleshoot them. And I'll show you a little example. I think it will be easier to show. So first, we have a database with running HeatWave. It changes like the image. It has like a little fire behind it. And we can start, stop, rescale the HeatWave cluster. So you can just do this all from Shell VS Code plugin. So we want to change from one cluster site to two, for example. You can choose the shape and then run it, and it will kind of run as a task to do this. This takes a while, of course, rescaling the cluster. So yeah, this is running now. Takes a little bit. And what we will do is use the notebook interface after this to run some queries and see if we can offload them to HeatWave, run them locally, these kinds of things. So the cluster has been rescaled, and now let's connect to it. Create a notebook interface here, start a notebook using the Bastion session again. We are showing the schemas, so we have the HW, the HeatWave schema, with a test table that has some random data in there, basically. So we can run the select count from HeatWave.test table. So there's 2 million rows in there. Not too much, of course. HeatWave can have a lot larger tables, of course, but as an example here. So we can run a query, and when we run the query, we have a button on top to say just run it in HeatWave, run it not in HeatWave, so you can do like the forcing or not. When we run this query in HeatWave, there's an error, and normally you would have to run a optimizer trace. Let me see if I can pause this for a second. You have basically the std function at that time was not implemented yet in HeatWave or not working. Well, you can run this query, and we will fetch the optimizer trace for you, and it will say, okay, these aggregation functions are supported, other aggregation functions are not yet supported. So it will show you this secondary engine, HeatWave engine failure, which makes it a lot easier, because in the past, or if you use a regular client, you would have to enable optimizer trace, run the query, you will get an error, then you have to select from performance schema, optimizer trace, there's a big output, and in there is that little error that we have here. So we try to make it easier to do so. Let me see, I need to restart the video. Let me move a little bit to where we were. Basically here. Okay. So yeah, now we can, let's say we want to take this out. So the optimizer trace. So you have this button there, run with HeatWave. So it's like a little lightning with the fire, execute in HeatWave. And you can, when we ran it previously, it took a lot longer, like a second. Now this only takes 155 milliseconds, because it's offloading it to HeatWave cluster, of course, so which is a lot faster. Next up is executing embedded SQL, where in some example code, we have some Python code here which contains queries. You can execute snippets in the notebook interface. You can update it and put it back in your code. So let's show how that works. So we have a Python here. We have DB objects, and there's some queries in there. And this query, let's say we want to use this query in our code, but we want to run it, see what the output is. Maybe we need to modify it a little bit. We just execute with MySQL Shell. You can choose the connection that you want to use, so localhost in this case. Run it. The query runs. And then we might be, okay, this is not really what we want. We're basically fetching all the routines from information schema and only the stored procedures. Maybe we want procedures or, so the procedures and the functions. We want to return both of those. So there's a couple more functions as well in here. So we want to use that. So now we want to put that back in our code. So we can just have a button there, and that says update SQL in original source file. You run it, it updates it, and it updates your code. So nice integration between kind of the notebook interface and your code. Next is some basic kind of administration things. So we have the MySQL administration tab for a while now, where you can look at the server status, and you can see all the kind of the main features. So this is MySQL's 8030 community in this case. It shows you kind of where the error log is located, what features are enabled. Are we using is thread pool on? Is the audit log enabled, the firewall, and so on. It's just a general overview of the server. Next to that, we have client connections, where it's show process list. But it's a bit more extended, because you have all the processes running. But in addition, we're showing some key metrics. But you can also see more data about that thread. What is that process running? And there's the hide details, show hide details. And it's showing you more details about the query. If it's holding any row locks, data locks, so it's using any metadata locks, any other InnoDB locks, any attributes that are assigned to that session as well. So you can look all that up just from within the interface. So quite nice to use. So show process list. And then, as an example, we connect to a remote server, and we want to look at the performance dashboard. So it's not a full-blown performance monitoring like the DBM that there's some sessions about, but it will show you some basic graphs, basic metrics on network, MySQL status, and InnoDB status, like what's the checkpoint age, what the buffer pool is, how many writes are going, how much traffic is going through the system. It doesn't have any historical data. It's quite just when I started, it will start collecting some metrics from time to time and output this. Yeah, any disk reads, things like that. So just a high-level overview, not a full monitoring solution. That's not its purpose. It's similar to what we have in MySQL Workbench, basically. And then as last, for those who hasn't seen this morning during the demo that I gave during the keynote, is the MySQL REST service. So we've recently launched a preview of our REST service where you can access your data through a REST, HTTP REST interface, where you can, write apps where the web browser queries the REST service directly to fetch its data. Maybe you don't need an application server for a lot of these things using this RESTful interface. It has OAuth 2 support. We have internal authentication. We have user roles, groups. We have hierarchies. And then also kind of row level security where certain users can only see data rows that are related to their user ID, so you can update your schema and assign that in the REST service. We have the user management, which happens through the MySQL Shell for VS Code interface. And then there's also command line interface, the MySQL Shell command line. You can use this as well to interact with your data, to configure the REST service, and so on. So I have a little demo here. It's similar to what I've shown this morning. Maybe a little less in depth. So we can configure this instance to run REST service. And what it will do is we'll create a REST schema in the database, which will contain the REST service configuration. And for purposes of a demo or development environment, we're going to start a router instance. But first, we're going to add a service. And we're going to call it the /myService in this case. So my service. We're doing HTTPS only. Everything remains default. We run my service. Okay, the service is being created. Now we need to add schema to it. And we're going to choose the Sakila schema. So we click Add schema to the REST service. We use that service, /myService. You can have multiple, and then we expose /Sakila with the schema name Sakila. We disable authentication for purposes of the demo. We can configure what the limit needs to be. 25 rows is the default. And then when we added the schema, we can add the tables. And we can add the actors table. So we can add that object to the REST service. And we add the service to the Sakila schema. The actors table /actor is how we expose it in the REST API. And then we allow reads only. So you can choose what operations you want. And we're going to disable authentication as well for this demo. And then we click OK. So now there's no router running yet locally. We still have to do this. Or it was running already in this demo. But I think REST, and now bootstrap or start. Start will do the bootstrapping as well of router. It knows it's a new router, so I have to rebootstrap it. And then you'll see how it starts, configures itself. It's in the terminal in the console, VS Code console. And we have my service, Sakila, and we have some data there. So now we can show this in a browser. So we open the web browser. And you can see this is in Chrome. The Chrome plugin extension is a little bit better in what I showed this morning. So we have all the data in JSON output, 25 rows by default. And you have links to each individual one. So you can do /1, /2. So if we add that, it shows a certain primary key value, basically. So you can see /2, actor /2 shows you the second one, which is Nick Wahlberg. You can actually click on it in the Chrome plugin, which is nice. There's a limit of 25 by default. So we have limit 25. We only show 25 by default. And you can do pagination with the offset. And you can just click on here to show the offset. You can also know, is there more rows or not, which is neat. So it's quite kind of easy to go over this data and then fetch more data if needed. You know if there's more data or not, and so on. So here we're doing an offset of 25. You can write your filtering in the query string, what data you want, you don't want, and so on. So this is using tables. You can also do this on top of views. You can create your own views, which span multiple tables, do aggregations, and then expose that to the REST service as well. So yeah, that's it. That's my talk. So download it on the VS Code Marketplace. It's available as a preview right now. Yeah, any feedback you might have would be interesting to hear about it. Just, yeah, try it. And then please rate the session, of course. Yeah. And that's it. Thank you very much. Thank you.